couple months ago, I made a video about climate change, and it got a fair amount of traction. And I published a note about climate change, and got a lot of comments. So the purpose of this video is to kind of update the previous work and to respond to some of the comments. And I hope you find this interesting. So my fundamental thesis and claim as it faces climate change is a couple fold. First, kind of being in the energy development business for a long time across a wide range of technologies, gas-fired combined cycles, oil-fired power plants in developing countries, wind, solar. I've always claimed that we really shouldn't use climate change as a rationale to support renewable energy. And in fact, renewable energy projects supported themselves based on their economic value. And I didn't really want to have a conversation and a debate about climate change because it's just a debate you can't really win, or at least you didn't used to be able to win it. Now, fast forward to today, I have a completely different claim as it faces climate change, which is the climate's already changed. So when we talk about there is no climate, we're really climate change. We're really talking about did it rain yesterday or not? And I'm like, why are we arguing about whether it rained yesterday or not? We can look out the window yesterday and it rained or didn't rain. It's a very poor thing to argue about because it's a question, did it rain yesterday or not? It's a question that's a very factual answer, did or didn't. So why do I say that the climate's already changed? And what did I do to kind of support this claim? I did something very simple. I went and got the data for the last 174 years, which is the data for which there are thermometers that are available. And I went to the UK Met Office website and just pulled the data down. There are other places you can get this data. You can get it from NASA, you can get it from NOAA, you can get it from berkeley-earth.org. There's a number of different ways to get data. It's not all the same data. It doesn't matter what data you use. The outcome is the exact same. So what do I do with the data? I just put it in Excel. So I'm not talking about a climate model. I'm not talking about anything fancy at all. I'm talking about just using probability methods that any high school kid in AP statistics could do for you. And in fact, just go have a high school kid that's in AP statistics just do this for you and convince yourself, or just do it yourself. So I took the data, I took the year, I took the anomaly, which is the difference of that year to the reference that they use. And I just computed standard statistics that you can do right on Excel. And you find that the mean was negative 0.156885, and the standard deviation was 0.3198. And it's just math. Like, there's just nothing fancy about this. I could have used more fancy math. The outcome wouldn't be any different. So we could use different ways to do the regression. We could do all sorts of fancy things. We could use all sorts of tools that are available commercially, and the outcome will be the exact same. So when I did this, what did I find? I found that the joint probability, the probability of having this year being hot and last year being hot and the last 10 years were all hot, what was the probability of that taken jointly? So, okay, you could have a hot year. And I hear that all the time. It was hot this year, is hot in 1933 or whatever in Texas. To which my response is, yeah, it was hot in 1933 in Texas, but it wasn't hot globally in 1933. It was hot in Texas in the 1930s, number one. And number two, it was hot but it was cold before then. It was hot, and then it was cold. It was cold afterwards. So it was just normal variation. In fact, as it faces weather and natural phenomena generally, they tend to have fat tails. What is a fat tail? A fat tail is there's a more of a likelihood than one would normally think of these outlier events occurring. The tails of the distribution are fat. They're bigger than you might expect. And that's definitely true in temperature and in rainfall and river flow down the Nile and all sorts of things for which this has been measured. There's really good books about this. Benoit Mandelbrot founded fractal geometry based on this observation. So fully agree. You can have a hot year, and that doesn't mean the climate's changed. There's no question about it. Absolutely concede. But what you can't have is a hot year, followed by a hot year, followed by a hot year, followed by a hot year, and every year is getting more and more hot. And so that actually is where we are today. And so I'm just going to show you. This is from Climate Stripes. You can, if you go to my website, this is in a paper. You can go download all this yourself. The links are all there. But what the issue that you have here isn't that these are hot years. They're hot years. There've been other hot years. The issue is that they're hot years globally. So kind of back to it was hot in Texas in the 1930s. Yeah, it was hot in Texas, but globally it wasn't hot. It's actually very rare to have a hot year throughout the entire globe. So if you go look at this entire 164-year history, I don't see a whole lot of hot years here. Well, not until, of course, we change the climate. And so in my previous conversations about climate change, going back decades, and I've had the conversation many times before. You're always facing the problem, because my guess is that year right there, that little hot year there, my guess is that's 1998. And so we had a hot year in 1998, no question about it. I don't know whether it was due to the climate changing. I don't know whether it was due to natural variation. It doesn't matter. But forever, those of us who thought there was a scientific basis for the belief in this climate change thesis, we're always having to, everybody go, well, the climate hasn't changed. It was hotter in 1998, don't you know? That was a very true argument until 2015. Now, 2015, 8 years ago. And every year since then, it's been hotter than it was in 1998. So, in fact, it's really alarming at how hotter and hotter and hotter and hotter the entire globe is getting. And so, just go back to this data series. You just kind of end up with this kind of key statistic. So that particular year, 1893, was 25% likely. And you see these likelihoods, that's this column M here. There's a lot of likelihoods that are 45, 50% likely. This year here was 1938. It was 50% likely. So it was a very likely year. A lot of years, 60% likely. Well, you end up coming down here into the 2000s, and now the year isn't very likely at all. Now the year is 25% likely. And then you come down here, well, the year's only 10% likely. So now that's, I call P10. The kind of opposite P90, just on the other end of the curve there. So it's only a 10% likelihood that year happened. Well, that was 2007. All of a sudden, we're 2015, we're P5. It's only 5% likelihood of that year happening. Now, here we are in 2023, And there's only a 0.3% likelihood that this year is happening. So three out of 1,000. So is it possible to have a 3 out of 1,000 year in a time series of over a couple hundred years of temperature data for the? Of course it's possible that would be natural variation. But what's not possible is every year to be this unlikely. So let's just talk about the last 10 years, and let's just kind of wander down memory lane. So 10 years ago was 4.8% likely, 4.3% likely, 3.7% likely, 3.1% likely, 2.5% likely, 2% likely, 1.4% likely, less than 1% likely, 0.3% likely. The likelihood of all those happening in a row being natural variation is called the joint probability. And the joint probability of those numbers all happening in a row is very, very low. It's really zero. In statistics speech, we call almost surely zero. So there is some chance that it's not zero, and I'll tell you what that chance is. It's 2.5 times 10 to the negative 10 to the 17th chance. So what is that? It's 2.5. It's a number with 16 zeros in front of it. That's zero. So the chance of so let me put that in perspective. The chance of winning the lottery is 2.5 times 10 to the 9. So this is 10 million times more unlikely than winning the lottery. I'm talking about the Powerball, the Mega Millions. It's not very likely. We don't plan our family budget around here saying, "Oh, I'm going to win the lottery." Well, not only is there a chance, vis-a-vis climate, I'm not going to go make public policy based on climate change. I might win the lottery. It's the same thing, except that the climate change is even more unlikely. It's 10 million times more unlikely. This is my point. The climate already changed. I don't need to talk about 1998. I don't need to talk about the science. I don't need to talk about models. I don't need to talk about human fingerprints, which are the signals of climate change and why we think it's climate change. I don't need to talk about any of that anymore. I don't need to spend 5 minutes on this conversation. I just need to say that, yeah, we've got 174 years of data. Here's the math. What did I do wrong? I mean, I'm happy to use different regression techniques if you want me to, but it doesn't seem like the outcome's going to be any different. So let me go just talk about Texas. So when you take the globe, it kind of tends to smooth things out. When you look at a particular point in time, it's more volatile, as you might expect, because this is Texas, and sure enough, in the 1930s, that would have been right about those are those numbers right there. I can make it look like this. I can make it look like that. So yeah, there were some hot numbers there, but the globe wasn't hot those years, and not only that, but you had the hot years, but you had the cold years. All we got now is hot years. So fortunately, because I was wondering about myself, I got a lot of comments. The comment I did not get? You didn't do the math right. So no one said, "Oh, I saw your video, and 2.5 times 10 to the negative 17 seems." I'm not arguing that that's not very probable, but you made a mistake in your math. I didn't hear that. I didn't hear that once. I am going to tick through a couple things that I did here, and I will respond because it's worth responding to. Then, I don't know how this came to my inbox or attention, but it just happened this week, and I'm glad that it happened. So sure enough, I'm not a scientist. I mean, I have a degree in physics, but I'm kind of a finance and power plant development guy. Um, uh, but these guys are scientists here. And what did they say? Well, they actually agreed with me. And they said, we looked at 2023, we looked at 2023 in Texas, and we found that there's an infinite probability that the change that you're seeing in Texas this year is due to climate change and not natural variability. So, in other words, the probability of it being naturally variable is zero, which I was looking at global temperatures. They're looking at these three different places in North America, Europe, and China as case studies. They used a lot more sophisticated methodologies than I used. But you know what? We came up with the exact same answer. The probability that what we're seeing today here in the United States and in the globe taken globally as being natural variation, that probability is zero. I'll say it's almost surely zero. Boom, study, answer zero. Link to this is, of course, in my paper, but I was very glad to have other people say things. So if you want information on climate change and you want information on climate change that's accurate, I recommend going to these wild and crazy people at NASA. They're really way out there and a bunch of lunatics, right? Well, I don't know. I think they have a pretty well organized webpage on climate change. So over the years, what have we heard people complain about on climate change? And one of the, and I have to tell you, like, I really don't mean to be disparaged in any way, shape, or form. People have been skeptical on this climate issue because, number one, I do believe, and it's a perfectly accurate observation, that there's something called fashion in science. And that is to say, a scientific theory becomes in vogue and everybody talks about it and everybody signs off on it. And if you don't, you're not going to be treated well by your peers. There's examples of that in climate change for sure, absolutely. And there's examples of that in physics. And I don't know anything about any other science, so I couldn't tell you. There's a very nice book about this by one of my favorite physicist authors, Roger Penrose, who actually wrote a book on the fashion in science. Of course, there's about particle physics, but same thing. Number two, no doubt this is complicated, and no doubt that these forward-looking models could have been way off. So, and there's certainly more to study. There's nothing more to study to know that man has caused CO2 to go in the air, and the CO2 that went into the atmosphere has caused the Earth to change. Like, we already know that, but there's plenty more to learn. There's plenty of gaps in the data. There's plenty of ways to make the models more granular. So instead of being on a wide scale, they end up being on a more narrow scale. There's all sorts of work to do. And there's no question that this is chaotic, getting back to my Mandelbrot comment earlier. And the fat tails is all kind of the same thing. So when someone says, don't you know that these chaotic models are very hard and they really depend on your initial condition, absolutely, on your initial condition, absolutely agree with 100% with all that. But doesn't mean that the climate hasn't already changed and we can't go get 174 years of data and figure out how much from the normal distribution this stuff is, because any high school kid can do that. And the outcome is clear. And when you do math that's more sophisticated than high school math, the way that the scientists did in the report I just said, you come to the exact same conclusion. And if I went and I did Arch and ARMA and all these other statistical models that are commercially available, in fact, they're on my computer, I come up with the exact same outcome. So the climate's already changed. There's no one, I'd love for someone to show up. Said I have this model, and if you do it this way, it'll show the climate hasn't changed. I'm all ears. Please call me up. I'll be happy to look at it, but it hasn't happened yet. So one of the guys that was a big climate skeptic was this guy, Dr. Mueller, and he said, "I don't believe your data. You're only using 20% of the data. You cherry pick the data. I want to redo the data." So he founded this thing called Berkeley Earth. He went and got money from the Koch brothers. We're happy to fund some climate denier guy. And Dr. Mueller's a real live physicist. He's a bona fide, not a climate expert, but definitely, I mean, he is now, 15 years later, but at the time he wasn't. And he's a smart guy, professor at UC Berkeley. And so what did he find when he went and put his own data together? He found that the climate changed. He found that the climate changed due to men and due to CO2. And just go to this Berkeley Earth webpage, all sorts of data visualizations on there. And sure enough, we want to look at some insights, which I found helpful because it kind of corroborated that the 2023 is really a hot year. It's a far hotter year than one would expect if this was weather. So here's all the years, and here's 2023. Here's all the years and the forward models in 2023. It's above the mean, the expected mean. Here's lots of years. Here's sea surface temperatures. Any way you look at this, like, we're just not seeing a year that's possible through normal variation. So now I'm going to just wrap up here. I'm going to talk about the comments I got from folks and what my responses are. So one, this climate skeptic thing, got to give people free pass for being a skeptic. Nothing wrong with being a skeptic. I addressed some particular skeptic comments. There's this Dr. Curry. She just wrote a book. No question, the woman was very poorly treated when she came out and raised her hand and said, "I don't believe everything everybody's saying about climate change." It was not treated very well at all. And but when you listen to her talk, she's not exactly saying that climate didn't change. She said, "Don't you know there's a lot of uncertainty around the forward-looking models?" Okay, that used to be important. It's no longer important. The other thing I hear is all those models that everybody did all those years, they were all wrong. That's not true at all. There's actually a study done about evaluating the performance of past climate change model predictions. There's a link to it in the paper. And it came that, this is the punchline. We find the climate models published over the past 5 decades were generally quite accurate in predicting global warming in the years after their publication. And that's my experience too. I went and I read the paper. I kind of read these papers over the previous few decades anyway. And if anything, I think they understated what we're seeing unfolding. Now, in the misinformation campaign, what people would do is say, "I have a model, and here's the high case, and here's my expected case, and here's the low case." And then someone gets on the TV and says, "Oh, well, that model was all wrong. Like, here was their case, and here's what actually happened. It really missed the mark." Well, they're benchmarking against the high case. They're not showing you the expected case and the low case. It's just misinformation. So if anybody ever says, "Oh, the models were all wrong," please realize that they might be pulling your leg a little bit. I don't believe in the data. Okay, we already talked about I don't believe in your data. Please go talk to Dr. Richard Mueller. Got a really nice YouTube on this. Go to his berkeleyearth.org webpage. Another one. Well, more CO2 is good. No, it's not. No, it's not. People are dying right now, all over the globe, due to climate change. That's not good. It's the opposite of good. It's bad. So the other thing is, there's all sorts of, and they're like, well, the plants are going to grow better. Well, yeah, the weeds grow better too. And they're not talking about the acidification of the ocean and the destruction of the low end of the food chain. And they're not saying, well, don't you know, where you can grow corn is going to go north and north and north and north. So all that prime farmland you're buying in Indiana, not such a good investment for growing corn 20, 30 years from now. You got to shoot up to Manitoba. But the problem with that is the soil up in Canada is not as fertile as the soil in America. So kind of net, even if you own the land up in Canada, it's not such a good investment. No, more CO2 is not a good thing. Links in the webpage. My favorite one, the favorite piece of misinformation is people go and say, well, here's the time series for the last 400,000 years or 800,000 years or 100,000 years, and it all starts from present day and goes backwards. Well, a lot of times present day is presented on this study is 1950 or 1960. Guess what? It's before the climate change. It's before all that red stuff there. And so, yeah, if we take this snapshot in time and we don't include the red stuff, we look pretty good. But if you include the red stuff, we got a big old problem on our hands. And so the other thing people do is these charts very typically tend to be a particular ice core in the Arctic or the Antarctic, or sometimes a combination of the two. And well, guess what? If two samples isn't representative of the whole globe. I mean, it's a very useful and interesting piece of information, but it's not telling you the whole picture. So some guys did a study on the whole picture, and then we talked, and they found the global mean surface temperature of the past 24,000 years, and they wrote a report. I'm just going to give you the conclusion of the report. The last glacial maximum data series. So in other words, we've had these 100,000 year cycles where we had the glaciers, and then we had warming, and then we had glaciers, and it was a 100,000 year cycle. The rapid warming part of the cycle, was 20,000 years. So in 10 to 20,000 years, the temperature increased, and then the glaciers melted, and here we are. We're actually at the end of one of these glacial warming periods, just kind of in this long-term scale analysis. And yeah, I wouldn't be here making a YouTube video talking about climate change if I thought that we were going to experience a change over the next 20,000 years. Yeah, I would care less about this. But you know what? We're experiencing climate change over a period of seemingly days, certainly tens of years and years. So it's a time scale that's the problem that we're seeing now. So this thing's just going shooting off the earth. And shooting off in a way that us old humans, might not survive. Our economy certainly might not survive. And what happens when we have 1 billion people that can't eat themselves? Like, we have a problem at the southern border today. I mean, what in the world's going to happen? I talked about the other one is, it was hot. It was hot in 1930. We already talked about that. The main observation I have and I'll wrap this up right now, 29 minutes, 30 minutes. I know everybody turned themselves off in about 15 minutes anyway. My main observation is, what people don't say is, no, the 174 record does not have this joint probability, and the probability of climate change due to human forcing, this due to natural variations, not zero. It's the math is wrong. They do the numbers some other way. People don't say that. What they do is they say, I want to talk about the dinosaurs. I want to talk about Al Gore. I want to talk about some model. I want to talk about uncertainty. I want to talk about Texas in 1935. I want to talk about sunspot. None of that shit matters, guys. not a bit of it matters, because we're not talking about will the climate change. We're talking about the climate already did change, don't you know? I think that's why this is such a poor political issue, because if we keep saying, oh, the climate didn't change, the climate didn't, it's just not natural variation. The numbers just don't support it. So let's, now my next video on this is going to be, oh, well, if you put that renewable energy, you're going to ruin the global economy. Well, I don't think that's what I'm seeing happen from my perspective, and I'm right in the middle of it. So that'll be the next video. Thanks for watching, and I'm going to post my paper, and I hope people read it. And I'd love to get some feedback, because sure enough, if I'm wrong, I'm going to post a retraction video.